Alrighty, ladies and gents, welcome back. In this video, we're going to go over how to write the electron configurations for ions, which are atoms that have either gained or lost electrons. Remember, you can either have a positive or negative charge depending on whether or not you've gained or lost the electron. So for doing these types of electron configurations, do not use the noble gas configuration. Always write out the full electron configuration. And another thing to keep in mind, and something that you should remember from regular chemistry, is that when an atom gains or loses electrons, it always loses it out of the outermost energy level. So when we write these electron configurations, we're either going to add electrons to or take them away from the last energy level, or the orbitals that are furthest away from the nucleus. So let's start with potassium. Let's write the neutral electron configuration for potassium, and then we will write the ion notation for it, okay? So let's go through the process here. We start with 1s. So we got 1s1, 1s2, 2s2, 2p6, 3s2, 3p6, and then finally 4s1. Now, this example says calcium has a positive charge, more specifically a +1 charge. Okay. If it has a +1 charge, that means it had to have lost an electron. Okay. The only way to become positive is by losing electrons, and we will lose that one electron from the outermost energy level, which in this case is the 4s orbital, because that's the highest one. It's the one that's all the way furthest away from the nucleus, if we imagine the nucleus is over here. So we are going to take away one electron from this, which means this technically now becomes 4s, no electrons in that orbital anymore. And because there are now no more electrons in that orbital, we will completely erase it. And then we now have the ion notation for potassium, which strangely enough also happens to be the same electron configuration for the noble gas and the previous energy level. And we'll talk more about that when we get to the bonding unit. Let's do the same thing for chlorine now. Let's write the neutral electron configuration, and then we will determine the electron configuration for the ion. Okay? So chlorine is 1s2. Oops. 2s2, 2p6, 3s2, and then 3p1, 2, 3, 4, 5. Okay. Now, it says that chlorine right here has a -1 charge. In order to become negative as an atom, you have to gain electrons, okay? And when you gain electrons, you always gain them in the outermost energy level, which in this case, the outermost energy level is the 3rd energy level, and the orbital with the highest energy is the p orbital, okay? So we are going to, in order to get a -1 charge, that's the same thing as adding one extra electron on. So we're going to add one extra electron, which means this now becomes 3p6. All right, so let's erase that and replace the 3p5 with a 3p6. And that is the electron configuration for an ion of chlorine. All right, let's do phosphorus next. Okay, let's go through the spiel. We'll start with the neutral, and then we'll get the ion. Okay. 1s2, 2s2, 2p6, 3s2, 3p1, 2, and 3. Okay. Now it says phosphorus here has a -3 charge. Again, as you know, you can only become negative if you gain electrons, and in order to get a -3 charge, you have to have gained 3 total electrons. So we are going to add 3 electrons to the outermost energy level, highest energy orbital, which means this 3p3 now is 3p6. We shall erase and then replace it with the correct orbital. It now has a full valence shell of 8 because this adds up to 8. Who remembers my little phrase, 8 is great, mate, don't leave it up to fate? Alright, ladies and gents, that is the quick and easy version of writing electron configurations for ions. If you are becoming positive, you are taking away electrons, so you will subtract from this number here. If you are becoming negative, you are adding electrons, so you will add to this number here. You add or subtract depending on the number that's right here, okay? Becoming positive by 1 means you're subtracting 1 electron. Becoming negative by 1 means you're adding 1 electron. And becoming negative by 3 means you're adding 3 electrons, just as a quick review. Okay, ladies and gents, this will do it for this video. Go ahead and try out the end of section quiz, and then we will see you for 1.6.